Hi, Mark.
No back. What's
Not
happening,
sure,
buddy?
buddy. We are waiting for people to join.
Morning.
So, I
Oh,
don't know if you saw my
Hey, good
hey
morning.
Steve, what's happening? Hey Michael.
Michael. Oh my God, we have a
Yeah, Michael's back.
JP Morgan tour de force here today.
I may not be able to stay for the whole meeting, but I figured I would
That's
join at
right.
least once. Yeah.
We're gonna
Well, we got Mark here, so that's much better. Both Marks. Mark squared.
there you go. I like that. We got a loud talker in the area. Might have to go on mute. Not to digress, but Mark Novak, was the little bit of location talk in that attestation meeting, is that in scope of this? I
Location
thought,
talk. What do you mean?
well, it's sort of something near and dear to my heart because it's occurred to me that if you know knowing whether, for example, a platform is in a hacker's garage versus in an Azure data center
So
is
that is going to be handled under attestation and workload identity.
oh, okay. So
There
this is
is
governance. Okay, I'm sorry. You're
well, yeah,
right.
this is
I was
this is
yeah.
governance, and so platform binding is something we need to figure out, and it's yeah, it's not trivial, but it's
Well,
not governance.
yeah. Yeah, I think, I mean, to me, it's, you just, at some level, you can't, if we talk specifically about location, you just can't provide it with the same level of, sort of integrity as you can
Well,
provide.
okay, so
But maybe we should hold off.
it's not the same, but let me sort of give you my perspective on this. So
Okay.
this, like I say, everything in security has a real world equivalent and just need to look. And that can be very informative. So
Yeah,
when I say I trust some people with my children, other people with my money, but they're not the same people.
sure.
It's exactly that. I trust my verifier to tell me about my workload, and I trust my like a TPM-based attestation service to tell me about location. And I wouldn't swap those roles, right? So it's it's in no way a diminished level of trust. It's a different level of trust,
Okay.
right? So
Yeah, I mean, yeah, maybe I'm a little biased toward, few keys and fuses and harder roots of trust and things, but yeah, I hear you. I agree.
okay, so I'm good. So as usual, putting things into the chat. So meeting minutes, which I just started, and I put all your names in there. And the other thing that we will be looking at today would be the reverse proxy governance pattern. And before we get too much into that, I want to mention the things that are going to be coming down the pike for. So you've seen, so the consortium has approved the 3 governance patterns we've developed so far. This is great news.
That's great.
And there'll be some changes to that. There'll be living documents, and one of the things I wanted to actually, so let me actually bring this up. So we used for 2 of the patterns, we used payload, but really, I really think we should be talking about workloads. Like payload, we talked about payload slices, and this is in terms of composite workloads, and that term has meaning there. But I really think we need to go to payload upgrade and payload governance and replace them with workload. I wanted to hear your opinion, just as a matter of synchronizing terms, and it's before the documents get
we talked about that in a previous call, and I think it was with the attestation group. There was some confusion between the 2 terms, and I'm totally fine with workload.
Okay, so I'm going to file an issue. Hold on, let me do this. I'm going to start sharing my screen here. I'm still booting up. It's 7 on the West Coast, but I've had my 5 a.m. meeting already, so I've been up for like 3 hours. It's still a little slow, so apologize. I'm gonna rearrange some windows here so I can start sharing my screen, and we'll dive right into it. So that's one thing I wanted to mention. That's like minor and procedural. The other thing I wanted to mention was that after we're done with reverse proxy governance, which I think this is going to be much less complex as a as a project. Reverse proxies are fairly well understood, so we're not going to spend, I believe, a whole lot of time. Besides, there is a lot of similarity with verify. So after that, the big rocks are going to be share my meeting minutes. So first thing was said, payload, payload upgrade, governance patterns to be bulk renamed to workload. Okay, so I will do an issue. Yeah, so the big rocks are going to be in the governance of this whole bill of materials. This is cross cutting with the workload identity group. So we need to figure out, and this is, and I put into the email that I sent out. So Mari Spina has done a, under Whimsy, I believe, a pull request. Let me see if I can find it. Bring it over here. So identity and assurance levels. Bring this in here. Workload machine identity assurance levels. So this works in both into composite workloads, right? So when we talk about, yeah, this is machine assurance, this is workload assurance. So these documents should be reviewed. I strongly suggest that we take a look, because this is also in the context of MITRE. So that's going to be one big rock trying to figure this out. Another big rock, really, really huge rock, as far as I'm concerned, is governance of machine learning models. So as we may have discussed in the previous calls, this machine learning models are very much a world apart, because the data is the code, right? So, and also data is vastly bigger than your typical piece of code that, your code could be 10 megabytes, a model can have 1 billion parameters, right? Or billions of parameters. And with RAG, the augmentation stuff, the model changes, right? So just figuring out the architecture, the building blocks, the composition of these things, and how to make sense of them, to know that you can have predictable behavior, especially as we go into agentic AI, right? So this is between attestation, workload identity, and governance. And I don't have any answers other than it's time to start thinking about this. So Zvonko,
there's a practical problem here that the industry is trying to solve with trusted IO. So given the sizes of the machine learning models, everybody's using GPUs or groups of GPUs.
Right.
And there's a performance hit at the moment getting data out of confidential computing into confidential computing in the GPU.
Yeah.
So there's the trusted IO spec that nobody's sorted out exactly how to get that established and working yet. So we're still waiting for hardware to finalize and get our hands on it and play with it.
Yeah, so I have a little insight there. If we, I know the TDX Connect guys at Intel, that's their version, right, Steve? And then I guess SEVs is SEVIO, I think they call it. Yeah, it's sort of interesting is trusted IO historically in the confidential computing space for me anyway, sort of a client thing. How do you get your like fingerprint reader, sort of confidential computing, but now, yeah, IO in this context definitely means efficiently getting the data over to the GPU or the everything over to the GPU basically. But Mark Novak, I think, is also just referring to maybe the amount of decrypt, encrypt, decrypt that has to happen as you go from.
Actually, no, it's not about that at all.
Okay.
It's okay. So, as you probably know, GPUs don't encrypt. So there is no encryption in the paging path. And the reason is that the memory of the GPU is on die, as opposed to in your typical PC architecture, that you have a separate bank of memory that is not on the CPU itself, right? So your memory is on die; it's physically inaccessible. So you basically have to destroy the GPU right. So they don't encrypt. What they do, however, oh, I just realized I had my video muted this whole time. Yeah. So what they do instead is they, yeah, it's all done in the clear. But what we need to worry about is the model itself. Is it, the thing that you measured? Like you still need some equivalent of code signing. Right. And again, like, and I need to look deeper into this with RAG, your model changes, and your code typically, once you hash it, it doesn't. So this is a change to how we think about it, right? And again, I don't have answers, but I'm posing the question because if we're going to start making strong guarantees about this is what your AI agent cannot do. Based on the assurance that it's that entity. Well, if the entity is fed in different model, it's going to start doing different things. And then your assurance is then seriously weakened. So,
yeah.
Okay.
Steve understandably brought up the IO, and I think you're referring to the encryption that sort of happens transparently with, say, TDX. But literally when you go from the model owner to, like Steve said, the quote unquote computational computing, which we think of as being more like the AMDs and Intel processors or AWS processors, to the GPU, then you've got to do sort of quote unquote software encryption, right? So that's. But but they know how to distribute these models across like hundreds and thousands of GPUs, right? So in simple-minded solution is just make sure that it's always encrypted as it when it's not inside the GPU. To your point, where we know that everything is sort of safe because these GPUs have so much memory on die or whatever.
Symmetric encryption.
But there's a second problem that Mark is bringing up, that a lot of ML systems continuously adapt. Not just RAG. RAG's the latest of the LLM stuff, but even in classical ML, so that the concept of identity is different because the weights that go into the system are the things that define the behavior. That's effectively the code. And if you allow the weights to modify, so they mutate as you use them and they adapt to the signals that are coming in, then the concept of identity is a lot harder to pin down. It's a whole different can of worms.
Good point.
Right. So anyway, I would encourage you to start researching this and studying the subject because, and again, I asked Zvonko Kaiser, he's probably closest to all of this. He said he's going to get back to us. This was not discussed in yesterday's attestation SIG meeting. They were busy talking about other things. But we're going to have to come back to this, and we're going to start chipping away at it and breaking it down. Again, big rock will probably take us a while and an interesting engineering challenge, and we'll need subject matter experts.
Yeah, I was going to say it might be useful. We have an internal resource, Dan Stocker, who recently joined. He's helping to craft a lot of the governance and controls thought within JP around AI and AI agents. But he's also very familiar with confidential computing as a concept. So it might be useful, and I'm fine to handle the reach out, Mark, if you want, to maybe loop him in on some of this.
Yeah, so we can have the conversation inside the firm on that, and then bring
Yeah.
the necessary experts here. But again,
Yeah.
so I see here, you know, Janita from Intel and Steve. Let's start pooling on, you know, experts that we can contact, explaining the problem, and start trying to understand, you know, where we might move with this. Again, you know, and in this SIG, we've actually been at the forefront. Like, we've realized governance is important before anybody else did. And you know, this is again, our job is to look ahead, because if we don't, then by the time, you know, something gels, it's not going to be governable, and then the benefit of confidential computing is not there, because, you know, you're not really setting or achieving any promises. And with the world increasingly becoming ML, this becomes, again, much like workload identity, an existential feature to get right. So again, big rocks coming up. Let's see. So reverse proxy governance. This is what happened to this document in the last 2 weeks. Since the verifier pattern got approved, I went and basically, you know, there were some changes in the review, whatnot. I tried to bring those changes into here. And so, for instance, we no longer have a hardware owner, we have a system operator. And the system operator is where we talk about hardware and option, the operating system. So in the stack, is the operating system of the reverse proxy part of, you know, system operator purview, or reverse proxy service purview? We don't know. It depends on a particular, like, it could be that I'm just renting bare bones hardware and I'm running my entire stack, in which case RPS owns that. Or it could be that, you know, RPS is this just, you know, container or whatever that runs on an operating system that Microsoft maintains. In that case, they maintain the hardware in the operating system, and I'm just like a VM in there. So that's where the line gets a little redrawn. Again, the verifier pattern already says that. So that's the first sort of general rename. You know, reverse proxy service, reverse proxy tenant is the same. There are comments. Please feel free. By the way, let me stick this in the chat so you know exactly what we're looking at. I'm just walking you right now through the
You know, whenever you have something optional in a role, I often think maybe you just need to make it 2 roles, and you know, you've got the hardware operator, and then the hardware operator is going to have the OS for the host, and then the guest could be the proxy.
That could be. It's I would like to have fewer roles. Right. And in this case, I think there is really 3 roles, in that there is where it runs. There are you know, the service to me, service to tenant is like hypervisor to virtual machine.
Yep.
Right. It's a resource provider, it's a control plane, it's the hosting environment. What goes into which, I think it's okay to leave it sort of flexible like this. Maybe there is a service that's like runs directly on bare metal, like, you know, some databases don't need an operating system, run directly on bare metal. You know, not for us to say. It's just the wording needs to be careful, so no confusion results. So okay, now clients and servers. The client and servers are per tenant, so this is different from verifier. In verifier, there is the attester, and that's, you know, that's it. But here, and by the way, later I created this pretty little diagram. You can look at it. That's under the solution, or maybe I can put this elsewhere in the document. But anyway, let's see. Nothing really changed here. I kept change tracking on. Under forces, I added. All right, so security and trust concerns are going to, for the reverse proxies, are going to encompass also things like availability and it's gonna, let's see, talk about protecting tenant policies that were kind of a separate item under verifier, but here it made sense to roll them under security and trust concerns. So we can review that. And then I added number 6, which is conveying trustworthy workload identity. right? So a reverse proxy between the client and the server, the moment you introduce workload identity into it, it needs to present the right identity to either side of the equation, right? So and also as reverse proxies sometimes are deployed in series, like one does WAF, one does DLP, one does this, one does that, right? There's sometimes several. As the body of requests and responses goes through these reverse proxies, the identity also needs to somehow travel with it. We need to figure out what that means. So that's why I basically put that under forces. Now, again, forces section of the pattern is what makes solving the problem outlined above hard, right? So we have that. Again, if you just review this, and if I can have your approval to just commit this change.
Well, I think it's fine to commit the change. I will need to review the whole doc.
Well, just do you believe that the
Yeah,
content of this paragraph is
yes, I do.
appropriate? Because we can always change it later.
Yep.
Okay, so we're gonna accept that. And then under solution. All right, so a few things here. I spoke, working at the bank, we work in jurisdictions that, we have little trust in. You can imagine what they are when you're a global institution. So as a result, the reverse proxy governance, even without confidential computing, becomes a significant concern. And one of the things that you worry about is that reverse proxies, because they're multifunction, right? So that's what sets apart from verifier. Like verifier is sort of a single function device. Like there's here are your reference values, and here are your quotes coming in, and there's some attestation results go out, and whatever. So it's a single function thing. Reverse proxies, because they can do WAF, and because they do DLP, and because they do any number of things. They may want to do just, content inspection or fraud detection or like any number of things. Effectively, there is one reverse proxy mainline sort of thing, and then there are extensions, extensibility points. You can load this plugin and that plugin, whatever. Right. So you effectively have a situation where one tenant runs not just different policies from its peer, but potentially different code. And I wanted to capture that in here. Right. So we're under verifier. We basically said the tenant runs the most current policies. Here we're saying the most current plugins and policies. But I do not know if there is a better term than plugins.
Yeah, I'd have to go work with my IT guy to figure out. Let's leave plugins for now.
Okay, so all right, so I'm just putting this on you, Steve, then. Thanks for volunteering. All right. Okay, so the next thing I brought in, this is from verifier pattern, protect tenant policies. So again, confidentiality should be required. So people don't necessarily know what policies you have. That who knows? Maybe you should just understand the implications if you don't. And integrity must be maintained, and especially with confidential computing. You don't trust your hosting environment, so you cannot be guaranteed the integrity of your policies. So that, again, that's a carryover from verifier. Then we talk about lifecycle management of signing and encryption keys. And again, the signing keys are present if you have certificates that may come with the identities you present. And encryption keys are for protecting data at rest. So here we talk about temper evident auditable changelog. We talk about bring your own key. We talk about key rotation. None of this is confidential computing specific when you come to bring your own key and key rotation. This document could be specifically just these additional things that you need for reverse proxy if it's running confidential computing environment. But I'll give you a little secret. I am trying to figure out how to formalize reverse proxy governance generally, just as part of my other day job, right? So as part of just control design. And this is why, to me, it made sense to dump all the considerations here. And the only thing here is, the protection of your keys with confidential computing is a different matter than it would be if your tenant was not isolated. And here I claim that it pretty much has to be, a reverse proxy needs to have trust execution environment, if it is to, if the entire setup is to be trusted. So anyway, the bullet points C through F are effectively straight out of verifier, but they were separate bullet, separate top level number there, and here they're just under security and trust concerns. If that's okay.
Hey,
So
Mark,
again,
still being new, just one thing that would help is, is your comparisons to verifier, I think I get, but is the implication that reverse proxies are in the TCB?
yes.
Okay, and that's because
Well, they're in the TCB for requests and responses, right? They're not necessarily in the TCB for the entire processing, right? But but if you think about it, if my trusted execution environment is dealing with executing trades, and through the reverse proxy, I'm obtaining, I do not know, market information, and market information is messed with by the untrusted hosting environment, I'll be executing bad trades.
Yeah, I mean, we're really only concerned, or maybe we're maximally concerned when the reverse proxy is opening up the TLS so it can make decisions about the content and route accordingly.
Yeah, okay.
Or modify content as they do.
Modify content, yep, like a WAF.
Yeah.
Okay.
That's why they're basically saying, we effectively need to run the tenant section of the reverse proxy in a way that protects the confidential computing expectations between clients and servers.
No, it's good. Okay, got it. Thank you.
So availability and performance, nothing changed, because again, the straight copy of what verifiers do. Regulatory and compliance. So there was not regulatory and compliance section under verifier, but reverse proxies are in the world that the JP Morgan part of today's call lives in. You deal with payment card information data. You deal with privacy sensitive data. So you're subject to GDPR and this and that, right? So as a result, we basically call out and say that your reverse proxy needs to be compliant with all applicable regulations, which with verifier probably doesn't have that much. It doesn't, like, it deals with
it's whatever
hashes of code and data.
Regulations are required for the data that it's going to handle.
Yeah, right. So basically, that's all it says. Deploy approved policies currently in effect. You need to know what they are. Need to be periodically tested, etc. So again, as usual, I ask for your approval too, so we can just treat this
absolutely fine to put in there.
How about this?
Yep.
Okay. Balancing security and privacy. So here we talk about, remember the full and partial model. This is where you, on one hand, you can have up, only transport level protections, and then that's the full model. Your reverse proxy sees everything. Or you can have partial model where there is effectively corresponding to application level encryption, where some stuff is hidden even from reverse proxy because the client and the server have their own application level protocol. And all it's and I added in bullets C is we're not telling you what to do. Like, you strike the balance.
Yep.
Okay.
And that's appropriate. There'll be applications that have encrypted payload that even though the reverse proxy is cracking things open, it's not going to be able to see what that payload is. And that's, entirely up to the application to decide. Right.
And again, system of record considerations are the same. I just added approved retention period to logs. I'll just approve that. Now, this one I'm not prepared to speak to yet because we don't have the workload identity business finished. Does that make sense? But
We
I'm
captured some of what we expect it to be, but if you want to wait till that second doc comes together, that makes sense.
sorry, what do you mean by that?
So workload identity, I'm assuming you're talking about some of the docs like the MITRE docs that we referred to.
Yeah. Well, I'm specifically so remember we added this number 6 here, that you
Yep.
need to convey trustworthy workload identity. And I'm simply saying I said that as one of the forces, right? So I'm saying that is an issue, but I just don't know how to solve it just yet. No, I don't
That's
know
fine.
enough to speak about this in confidence. Okay, so that's why I'm basically saying this section needs to be finished. And that probably not for today, unless we want to discuss some of this. I'll tell you what I think. I think that when if I put a reverse proxy around a backend workload, then I need to have an out-of-band mechanism to ensure that the workload identity that is response to the backend is presented to the client. So we need to basically issue the appropriate credential, right, of the workload with appropriate claims. So when the client connects and says, "Oh, this is, this is the application that I'm talking to. I'm talking to the payroll application," and who cares that I'm talking to the reverse proxy, not to the actual, backend that's doing the payroll application thing. By the way, Whimsy talks about that. Right. In Whimsy, you in fact do have an identity at the proxy.
This this will be a big topic. What is the identity of a composite SOA application that's made up of multiple workloads? And as a client, if you want to test to the identity of the server you're connecting to, in any modern application, it's not likely to be a single component that you're talking to. It's likely to be many things.
Right.
And so what's the identity that you want to verify? That's not a trivial question to answer.
Well, I think it may actually be simpler than than it appears. So let me give you some thoughts on this. So if you remember, I talked about it in this when you joined the Trustworthy Workload Identity SIG, and we talk about that. There are 3 types of identities. By the way, Whimsy talks about that in similar terms. So there is sort of what I call the identity you present to the outside world for incoming authentication. So, I'm the payroll application, and perhaps that identity is surfaced by the reverse proxy to anybody who wants to interact with the payroll application. And that's one identity of this complex workload. Now, inside of it, that may be different. So the second type of identity is component parts of the payroll application that do their separate things. They have their own, identities for purposes of least privilege, but none of them claim to be the payroll application themselves. And those are within the trust domain of the payroll application. They don't go outside of that trust domain. And finally, when the payroll application or parts of the payroll application want to go reach out to, say, the payroll database, they need to say, well, I am the payroll application authorized for this portion of the, payroll database. So, to make payments or change, who makes what kind of money, whatever, right? And that's a third type of identity. It's the identity that a composite workload presents to the outside world, and leaves the trust domain of the payroll app.
Yeah, but the question we're asking here is, so let's say I'm Oracle and I have a payroll application as part of Oracle ERP, and there's a reverse proxy that I ship as part of the application that does load balancing.
Yeah.
right? So it's an Nginx server that sits in front of the payroll system, and it splits up the load to multiple machines. And this is part of the application. And it's entirely appropriate that the external ID that's presented as the application ID is sourced from the ID of that load balancer, and the load balancer has to establish its own trust with the various components behind the scenes, but it's going to present its identity to the outside world. Now I buy this system and I install it at my organization, and I put a WAF in front of it, which is part of my organizational requirements that I'm going to do some payload filtering in front of the application. So now a client coming in from the outside world is going to see that WAF first before they see the load balancer that's part of the application. From a technical person's point of view, I've just got two reverse proxies sitting in front of each other. Why is one more important than the other? What's the payload? What's the ID? What's the identity? I do think it's a decision that needs to be thought through and best guidance provided that says, here's, how people should think about it generally, as opposed to getting lost in the details.
Well, so I think that this needs to be decided in the workload identity SIG, and then the results need to be brought back into this pattern.
Yep.
Because first we need to know what it is we're doing before we know how to govern it.
I will absolutely concur with that. It does mean maybe I should go find time to spend some time with the workload SIG.
Please, yeah, that's the next big thing. So I'm willing to basically accept, go through this, accept the changes that we have so far, and then basically resolve to, dedicate the time here to things that are, things we already know how to govern, and come back to reverse proxy after we do the workload identity stuff.
Yep.
So again, asking for permission to
make
you can
these
accept changes. So, and then again, this is finished discussion of discussing inside the TriSig. These are a bunch of to-dos I already included, as you could see, transport level, application level, logs of policy, etc. So that's all the to-dos have been accomplished. And that I can delete. Now there was somebody added. Who was it? Alec. He's not here today. Okay, this has already been done. What is this use case? CSP can provide protection for password dictionary attacks and WAF attacks. Not exactly sure. I guess I'll have to ask.
I think he's just worrying about a use case where Microsoft is going to be sticking their own reverse proxy in front of your systems. And so if that's transparent to you normally, but is no longer transparent to you in the confidential compute world, that functionality has to go somewhere.
Well, so the model there is effectively in AWS, that the AMI, right? The Amazon Machine Image. And if it comes from a trusted source, you basically say, yeah, I trust this. So you effectively pull it in and you incorporate it, and it's now yours.
Yep.
So it has to be, and it's a valid concern to raise. I'm just thinking that it's perhaps fairly easy to reuse that practice. I'm going to add.
Yeah, I mean, the simplistic view is anything outside of the enclave is in the untrusted space, and it doesn't matter whether it's in a reverse proxy or the network or routers or anything in between. Everything you expose outside of that TEE is potentially visible and exploitable somewhere along the line. And so if you want to prevent against that, I've got a piece of code in the server that's running in a TEE. I've got a piece of code in the client that's running in a TEE. They can always encrypt payloads independent of TLS or anything else that they can make opaque through that whole channel.
Yeah.
But
Okay,
there's
so
an infinite number of potential steps between the server and the client TEEs because you have no idea what's happening in the network layer.
well, I mean, we'll just have to use TLS throughout or IPsec or something.
Right, we're using TLS, but now we're writing a policy for what happens when you're inspecting the TLS via your reverse proxy.
Yeah.
Right. And ultimately, the assumption is if the client and the server really want to encrypt end to end, they could do so. And that's up to them. But the choice between the client and the server is knowing that everything between those two TEEs is potentially observable and modifiable.
Okay. Yeah. Okay. So, and I left. So the reason these ABCD are here is because up here I added ABCD. So I'm just tracking all the things that
Okay.
need to be done. And that's a very easy copy and paste from verifier. So I'll take care of that. Okay. So with that, I think this is as far as we can take the reverse proxy governance. I did not accept these changes. And I guess we will
You've
in
got
2
F
weeks.
as well.
Huh?
So that's F is still showing as a comment or as change that needs to be accepted.
Yes. Okay. So that's as far as we can take it right now. And I suggest we simply break today, and then we'll come back to some of our big rocks in the next 2 weeks.
Sounds good.
All right, then. Anybody else has anything else to add before we break? Mark, Janita?
Nothing from me. Just wanted to let you guys know we're making the edits to the GDPR document, and we'll have a final version in about a week or two.
Sounds good. All right. Thank you very much, and I will see you in 2 weeks.
Okay.
All right, thanks.
All right.
Bye-bye.
Thanks, Mark. Thanks, everybody. Take care. Good day.
Take care.